Okay, so I guess I should start now. In that case, hello everyone. My name is Magda. I'm a Scala developer at Software Mill, and I'm very happy to be able to be part of Scala Matsuri today. So I have been a Scala developer for, I guess, 6 years now. And right now I can say that I enjoy Scala. I like this language. I like writing it every day. But the beginnings weren't so smooth. I kept struggling to understand various concepts of Scala, and one of the things that confused me the most was implicits. And there were times when I thought, okay, I've got this. I understand implicits. But then I came across some other usage of implicits, and then I was lost again. And I had to go back to my more experienced colleagues and ask them, okay, I know we have talked about implicits, but can you please explain it to me one more time? What happens here in this context? Fortunately, my colleagues were very patient, so I got through this difficult phase. But I kept thinking, why does it have to be so difficult, so frustrating? So when I heard about Scala Free, and I heard that the concept of implicits is completely redesigned there, I get curious, and I wanted to know more. And that's how this presentation came to be. I wanted to share with you what I have learned. So during this presentation, I will tell you what implicits are generally, why we use it in Scala, why, in my opinion, they are so problematic. And the main part of the presentation is I will show you 4 use cases of Scala 2 and Scala 3 code so that you can see what are the differences, how we achieve the same things in Scala 2 and Scala 3. So implicits make us powerful. Generally, it's a very powerful, very important language feature. They are used to define so-called contextual abstractions so that you don't have to write anything explicitly in the code, but because your code runs in some context, the compiler can infer some of the things for you. And specifically, you can use it to provide some kind of context which you don't want to specify every time. You can use it to add functionality to some clause types. You can use them to define type classes, which in itself are a very important language feature. You can use them to provide implicit conversions, to handle dependency injection, to express some capabilities of your types, to compute new types out of existing ones, and to provide to the relationship, to the compiler, the information about relationship between some of the types. So generally, this one keyword can be used to achieve many different things to make sure that your code behaves exactly as you want it to behave. But also, there are some problems. Sometimes implicit make us miserable. And I think one of the reasons why that is so is that the implicit keyword can be attached to many language features. So it's not like you instantly know, you see some piece of code and you instantly know if it's providing context or doing implicit conversion. You have to know, you have to have experience, you have to know the idioms of the language to see what's being defined here. What is the intention of the author of the code. Also, it sometimes happens that you have some piece of code, it's working, it's compiling, but then you copy it and paste it to another file, and then it's not compiling anymore. And sometimes you lose many minutes or even hours trying to find out why the compiler doesn't like it. And then it turns out that you don't have some implicit import, which fetches for you something to the scope. I don't know, maybe a type class or something like that. And then it feels like magic. So it's like you have to have this implicit import incantations that you have to have in your code in order to work. So it can be quite confusing. And sometimes it can be the other way around. Sometimes you can import too much and you don't even realize that you have some implicit conversion in the scope. And then your compiler treats some types as if they are some other types. And weird behavior can happen from that. So how is it all different? What does Scala 3 bring to the table? Now, Scala 3, as you probably already know, is a major language rewrite. So it actually took 8 years to complete it from the first commit to the general release. But what's important for me is that the authors have decided to listen how we actually use Scala. So listen to our comments, look at the repositories, at the libraries, at the code that we see, that we do, and they have seen what are the pain points, and they have decided to address the pain points, the tricky bits, to make Scala free a language which is more pleasurable, more convenient to use. So it's probably not a surprise that implicits have been identified as one of the pain points. And the concept of the implicits was completely redesigned to the point where the implicit keyword is gone altogether from the language. You don't have it in Scala free. What you get instead is you have a couple of new language constructs where each of them does one thing and does it well. So let's see some examples. I'll show to you how to provide context in Scala 2 and Scala 3, how to add functionality to your types, how to define type classes, and how to provide implicit conversions. So let's start with providing context. If you define a feature in Scala, you probably in your code, you are most interested about the body of the feature can do. But you know that's not enough because you also have to provide some kind of execution context for the feature to run on. So if you actually look at the apply method for defining the feature, apart from the body, you also have this implicit parameter list specifying the executor. But you decide that this is some context and you don't want to write it here every day, every place where you define the feature, because you think it will clutter your code and make it messy, and you want the reader to focus on what's really important. So what's enough in Scala 2 is that you provide implicit value, for example, and that way you bring this execution context that you want to your scope. So this is how you do it in Scala 2. And now how is it different in Scala 3? You want to achieve the same thing, so you want to define the feature without bothering the reader about execution context at the start. And if you see the definition of the apply method written in Scala 3, you have this new using keyword. So this says that the method has to use execution context for it to work. And in the place where you want to provide the context, you have the given keyword. So this using and given keyword is the pair that is most important for defining contextual abstractions in Scala 3, and it's a pair that you will be using very often. So now let's move on to talking about adding functionality. So to explain it, let's imagine a sample domain. Let's say that we are implementing a website about books, about book recommendations. You can add the book that you have read and share it with your friends. And also there you have reading challenges, so that you can say at the beginning of the year that this year I want to read 10 or 20 books and share it with your friends. Let's imagine that our product owner approaches us and tells us that we need to add a new functionality because some of the users add books which are too short. They are very short, a couple of pages long, and they finish their reading challenges in January, very early, and it's not so fun for everyone anymore. So we like to add such a method called qualifies for challenge, and then it will compute to you if the book is eligible for the challenge or not. However, the problem is that our book class, this case class that we are working on, is defined somewhere in some package. We cannot really extend it. We cannot edit it. So what you do in Scala 2 for that, you can use an implicit class to add functionality to such a clause type. So we have an implicit class taking the parameter of the book that we want to extend, and the definition of the method is that the number of pages is more than 20. So this is Scala 2 using the implicit keyword. And in Scala 3, to achieve the same thing, so again, we have the clause type and we have the method that we want to add. We use a new language keyword, extension. This is an extension method, and it's a very good example of a thing which does one thing and does it well. So we have this extension method defined on our book type. This is the same qualifies for challenge method. And when you see this extension keyword, you instantly know what happens here. You instantly know that here we are adding functionalities to some clause type. So that's a small but very, very handy feature of Scala 3. And now let's move on to type classes. To explain that, let's imagine that still in our domain, some users tell us that they don't read such a lot of books, but they read a lot of articles, and they would like to take part in those challenges as well. But you don't want to count them the same way, because reading 10 books is not the same as reading 10 articles. So your product owner tells you that you need to keep some kind of a score and be able to add various items to the score. So you need to be able to add books, and then the books would be worth the number of pages that they have. And you need to be able to add articles, which will be worth just 1 point each article. So how can you provide such an add item method, which could work both on the book type and or the article type? If only book and article had a common parent, then you could use polymorphism, define some method in define polymorphic methods, and then the compiler would just sort it out for you. But unfortunately, it turns out that in our case, they are not related. So that's where type classes can come in handy. They let you add so-called ad hoc polymorphism. So you can specify some behavior for unrelated types. And the way you define type classes in Scala 2 is you need to have a trait. So in our example, a scoreable trait, this is our behavior that we want to have parameterized by the type. And then the implementations of the classes are implicit values here in our case, but they can also be implicit objects or defs. But here it's in an implicit value, providing an implementation of our scoreable behavior for the type book, parameterized by the book type. And then the implementation of the score method is the number of pages. And then we have an implementation of the type class for the scoreable behavior where the implementation is just 1. And the way we can use it in our add item method, so this is what we wanted to add, is that it's a method that is parameterized by the type. It takes an item, but also you can have a second parameter list with this behavior, this implicit scoring, which is your behavior. And the implementation of the method takes the current value of our challenge, of our points. And then what it does here is it asks the compiler to fetch the appropriate type class implementation for the type that it was actually called. So that's how you use type classes in Scala 2. Now, how is it different in Scala 3? You want to achieve the same thing, so you want to have the add item method. The implementation of the trait is the same. It's a scoreable trait for defining your behavior. But you define those type classes with the given keyword, which you have already seen. So that's a type class implementation for the scoreable behavior. You have the score method, and you have a type class implementation for the article, for the scoreable for the article type. And then here, very similar, you have the parameterized add item method, but here, as we have seen in the previous and in the first use case, you have this using keyword that you already know, and the compiler does what you wanted to here this way. So that's the type class implementation. And the last use case are implicit conversions. So to illustrate that, let's imagine that we want to print our books to the user interface, and somewhere in our code we have this beautiful print method, which has this unique and special implementation of printing the book, information about the book to the end user. But the problem is it operates on the item type. Again, this is some closed code. We don't have access to it, and we have a method that operates on the item type, but we would really like to call it on the book type, because here in our code, we are working with book types. So what you can do in Scala 2 is, again, use the implicit keyword for that. You need to specify an implicit method, have it somewhere in scope. In our case, it's called book to item, but it doesn't matter. What matters is that it takes the source item, in our case, book, and it returns the result item, and the implementation just tells the compiler how to provide the conversion. So here, let's just use the constructor using the book title. And in Scala 3, to achieve the same thing, so being able to call the print method on the book type, you have again a new feature. So apart from the given word, you have this conversion class. So this is actually a Scala.conversion, specially provided class, which is parameterized by two types, your source type and your target type. And what you need to do is to implement the apply method on it. And here again is our implementation. So again, this is the case of providing a feature of the language which does one thing and does it well, in the sense that when you see this conversion class being provided and implemented in your code, you instantly know what happens here is an implicit conversion between the types. So you want your compiler to treat some type as the other type. To sum up, I think the most important feature, at least for me, for a person who used to be very confused by implicits, is that defining contextual abstractions in Scala 3 focuses on the intention, not the mechanism. So the author can clearly convey what they have in mind, what is their goal, and not how they want to achieve it, not the mechanism. So the tools for that, the most important pair is the given and using pair. And together with extension methods and the conversion class, I think it's a new tool set which can make everyday writing of the Scala language a bit more easier, a bit less consulting the documentation. And also for the reader of your code, they can focus on what was your goal, what is your intention, what you are trying to do in the code, and not really how you want to achieve it mechanically. So thank you very much. If you have any comments or feedback about the presentation itself, then feel free to scan this QR code below or go to the URL below. And I'm not sure if we have any questions, if we have any time for questions. If yes, then I can answer them now. If not, I will hang around on Discord today. Thank you.